Welcome back, graded students. For today's lesson, we're going to be talking about the proportional relationship in graphs. We're continuing off from our last lesson, which was about the Cartesian plane or the coordinate plane. So, to move straight ahead into this, all right, we have three main points that we can follow if we want to see the proportionality in our graphs. Okay, so it says here we can test for proportionality on a graph, okay, by looking for various properties, okay. So we have three main points that we should follow. One is that a proportional graph will always go through the origin, no matter what. So it always connects to the origin, okay. So if it doesn't connect to the origin, that means that that graph is not a proportional graph. Now, the second point we have, a proportional graph will be a line. To be more exact, it should be a straight line, okay? So we are not allowed to have any curves or anything that's not straight in our graph. If that's the case, then that means that we're dealing with a non-proportional graph. Moving on to the third point, if you list points or the ordered pairs, if you list them down, okay, from the graph, okay, you can create ratios and see if they're constant or equal, okay? And we will be talking about that later on. So let's move on. Okay, now, here's an example of that, okay? In order to tell if a graph is proportional, the line must go through the origin and must be a straight line. So the example we have here, okay, already is a straight line and it touches the origin, right? So as you can see here, the first question is it a straight line? And it answers yes. Does it pass through 0, 0 or the origin? Yes, okay. So this is an example of a proportional relationship. And for the second example we have, this is another graph. And the questions we have, is it a straight line? Yes, it is a straight line. Does it pass through 0, 0 or the origin? No. Then this graph is not a proportional relationship. Okay, so it's very simple to actually see whether a graph is proportional or not. With those simple steps, with those three simple rules that I gave you earlier, which was these, okay, it will be very easy for you to clarify whether a graph is relational or not. Okay, now here are more examples. Grade 8. I want you to try by yourself to find out which of these graphs is proportional and which of these graphs are non-proportional. Okay? So I'll give you a few seconds. Okay. It's time we move on. So which do you think of these, which of these graphs are proportional? Of course, the first one we have over here is not a proportional graph because it has the curves, right? As you can see, it's not going to be a straight line, okay? It only has curves. How about for the second one we have on the bottom over here? This is also not proportional graph because it does not pass through the origin. As simple as that, okay? It does not pass through the origin and it starts from 5. Okay, it's time to move on to the third graph we have, okay? To the right side of this chart. So on the third graph that we have, So for the third graph that we have, all right, is this proportional or not? Okay, you can see it's straight, okay? It's a straight line and it passes through the origin. But if we actually look as it goes up, it doesn't have a proportional or constant ratio as it goes up. I'll be explaining more about that later on. Okay, so we cannot classify this as a proportional relationship as well. Why is that? For simple facts. Okay. Number one, over here, would be at 2.5, right? Am I correct? That's in the middle of 5 and 0. So we can say that it's 2.5. Okay? So it should be that when it reaches number 2, okay, the value of y should be only 5. But as we can see over here, okay, I know it's small, but it doesn't touch 5. Okay? It directly skips to about 6 or 7. Okay, you can see it's above this line, right? This is the line of 5, and it's no longer touching that line, meaning that it's more than 5 or greater than 5. Okay? So this chart is also not a relational or a proportional chart or a proportional graph. All right. How about for the last graph over here that we have? Is this going to be a proportional chart or not? First, we have to check. Okay, the value of our x increases by 5 every single time, or we can say that 2.5 because there's one line that they're skipping, right? But we can say it goes out by 5 every 2 skips. And then for our y-axis, we increase by 4 every 2 skips. Okay, so let's try and find out if we have a constant proportional ratio. How do we check that? We check the first point, which is 5. Okay, the value of x is 5. And then the value of y is going to be 6. Right? So write that down. So 5, comma 6. That will be our first ordered pair, right? Now, for our second point, we have over here, it's going to be 10, comma 12. Am I correct? Okay, so we have 10 as our x and we have 12 as our y. Okay, and then for our last point, we have 15, okay, and 18. Okay, so write it down as well. So this chart, all right, if you look at your ordered pairs, okay, if you line up all the x and all your y's, okay, so all x's will be in one column and all your y will be in another column. As you can see, we're going up in a steady rate, right? So 5, 6 becomes 10, 12, becomes 15, 18, right? So it's climbing up at a steady phase, right? So this is the only chart that is proportional. All right, so for this slide, okay, we have a table instead of a graph. So here, this proves, or this shows you the easy way, this shows you the easy way of knowing whether the table is proportional or not. Okay, so as I said, you need to know whether the ratio are equal. Okay, so here, how are we testing out if the ratios are equal? As you can see, they're dividing 10 or the y by whatever is the value of x. So over here, we have 10 divided by 5 is equal to, so they're not actually dividing it, they're just simplifying it, right? So 10 over 5 can be simplified as 2 over 1. Am I correct? So same thing they did to the next one, 6 over 8 can be 2 over 1. So as you can see, as we go down the table here, we have a constant ratio, which implies that we have a proportional relationship. Am I correct? Yes, because we have the constant of proportionality, which is 2 over 1 or just 2. Okay, so it's always that y, all right, the value of y is 2 times greater than the value of x. So we have a constant proportional relationship. This is an example of a non-proportional relationship. Why? As you can see, the ratio of our values over here are varying from one another. We have 3 over 2, 3 over 2, 5 over 1, 3 over 2, and 2 over 1. Right? So as you can see here, this is a very good example of a non-proportional relationship. Okay? So, it's your turn to practice. Okay? So which of this table is a proportional relationship and which of this table is a non-proportional relationship? So you can pause the video here and solve it, and I'll give you a few seconds. Right, I hope you're done. Let's move on to the next slide, shall we? All right, so here's some more explanation. If you're just looking at the ordered pairs, okay? So in order to tell if a set of ordered pairs is proportional, you have to look at the ratio of y to x. Okay? So this is the explanation for the table that we saw earlier, okay? But instead of table, we're just looking at ordered pairs, okay? To make it more simple for you, I advise you to make your ordered pairs into a table, which will make it a lot easier for you because you can do what we did over here. All right, we can solve whether it's proportional or not, right? So let's move on. All right. So now we have to graph a proportional relationship. Okay. Now we are given a table, okay? Our task is to create a list of ordered pairs, plot the points in the grid, connect using a ruler, and label the axis, right? Let's move on. So here's a table that we're given. We have hours, x, and miles, y. Okay, so it's really simple to plot, okay? So to plot the points, you just need to follow, as I have explained before, okay? You just need to follow what the value of x is and what the value of y is. Okay, so for example, we have 0, 0 here. So we have to put a point on x, 0, and then y, 0. So it's already here. There's already a point here, right? So that's where our first point is. And what's next? We have 1 and 3. So it means we need to go 1 right to the right, and then 3 up. All right? That gets us our second point. And then for the last point, 2, 6, we have to go 2 to the right, and then 6 going up. 1, 2, 3, 4, 5, and 6. There you go. And then you just have to draw a line, right, to connect all 3 points. And that concludes our lesson for proportionality.